Hi, Ben. Welcome back.
Oh, yeah. Hi, John. We are here. We're right here.
We've both been on vacation, and yet the podcast has continued without us.
It has, miraculously.
It's fantastic.
Somehow. People have been stepping up to do all kinds of things, which maybe we'll get into later, because we have plenty of time this episode, because not all Rust releases are of the same magnitude. And so whereas our last one was very large, like hour-long podcast about all the features, this one has fewer features, although still some great ones to talk about. So you want to just dive right into those?
Let's go for
Rust 1.38, here we come.
Do you mean 137?
137, here we come. Just leave it in. It's fine.
It's fine. All right, so let's do the same thing that we did last time and sort of walk through the things basically in the same order they're listed in the release notes, and then we have some more minor things that we'll get to at the end as well. And we'll talk about some upcoming changes as well for the next Rust release. But for now, let's dive in with enum variants through aliases.
Mm-hmm. Do you want to go over what these are?
Sure. So one thing that's been a little bit annoying if you've been using enums a lot is whenever you write an impl for that enum, you've had to write out the name of the enum followed by double colon and then its variants anytime you want to match on it. And this is a little bit annoying, especially if you end up renaming that enum. And now one thing you can do is you can just use self instead. You can say self : and then the variant in any impl block for that enum type. In addition, if you type alias in enums, you say something like type foo is option of U8, then now you can still match on the variants of that enum through the name of the type alias. And this is something that just makes working with enums so much easier, even if it's in a relatively minor way.
Yeah, it's one of those features that really, I think, exemplifies Rust development, where it's not a feature as in like this big whole new thing that you need to have a chapter on in a book somewhere. It's just a way of making what's currently there more consistent and kind of like it should work how I think it should work, because you expect to be able to make a type alias to an enum variant or any of these other things. Like, why shouldn't I be able to? And now you can.
It's really making the language less surprising,
yeah,
which is good.
And so like Rust does this a lot where it adds features that aren't really features. It's just kind of making what is there more powerful.
And it's interesting because the next feature on the list, which is cargo vendor, is a little bit similar in that it's not a feature that enables you to do things you couldn't do before. It just makes a common thing easier to do. In particular, cargo vendor is used for things like you have this giant executable or some giant project, and you want to ship all of your dependencies as part of your package. For example, rustc does this. For any extern crate that rustc uses, you need to include that with the compiler source when you hand it out. And so now there's a single command, cargo vendor, which will download all of your dependencies into a folder just called vendor. And now you have them all locally, and you can tar them up or do whatever you want with them.
Yeah, I think this tool was actually written for rustc by one of the developers, Alex Crichton. So yeah, it is well used, and it was upstreamed into actual cargo.
My guess is this has also been driven a little bit by companies that want to use this for like
Most
big
likely.
mono repos or something. Like if you're Google or Facebook or whatnot, you probably want to vendor your dependencies rather than rely on external sources like Crates.io, because you might do security audits or who knows.
Next up is using unnamed const items for macros. What is this?
So this is a relatively obscure feature that, as many of these obscure features are, is mostly there for macro authors, but you'll feel the effects down in the ecosystem. So what this enables you to do is similarly to how you can say let underscore equals and then some value. If you don't really want to give that value a name, you just want to sort of do the compilation and the compute of that value. And now you can do the same for const. So you can say const underscore equals some value. Now you might wonder, why would I ever do this? The const doesn't do anything in my program. And the reason is because maybe the best example of this is the static assertions crate. So the static assertion crate gives you a bunch of assertions that can be done at compile time. Things like how large is the struct, or does this type implement this trait? And it gives you really convenient macros for it. And one of the things that they do is, in order to check whether a given type is of a given size, is that they basically check that you can take a constant, you can assign an array of the size of the type to an array of the size of the value you're checking against. And they don't really care about the name of this constant because it's not going to get used anywhere. But previously, you had to give a name. And so the assert size equals macro, or whatever it's called, required you to pass in this arbitrary identifier that was never used for anything. And now that can be removed because they can just use const underscore.
Yeah, it's a really cool feature, I think. It kind of also, too, in the vein of showing off the sort of different branches of things that Rust tends to add. It is a feature, like you mentioned, made for macro authors. And there are a few things in Rust where if you're just using the language by itself, you look at it and be like, why would I ever want or need to use that? Like, for example, one-element tuples work. And it's kind of like, isn't that just a value? And you'd be right, but if you don't have that, it makes macro authorship much more complicated because you have all these like special cases now to handle. And so there are plenty of things there just to make things more consistent for macro authors.
And I think in turn for the users, right? So if macro authors are able to avoid having these hacks for special cases, that also means that they can write cleaner APIs.
It makes their code simpler, and then having simpler macros to read is always a great thing.
Exactly. The next item on the list is profile-guided optimization. Do you want to talk a little bit about this?
Sure. So this is kind of a use case for very extreme users. So Firefox and Chrome, for example, both these web browsers, they kind of use this technique currently on their C++ code through LLVM's implementation to kind of squeeze the last bit of performance out. So it might only increase like the final performance of various benchmarks by like 5, maybe at most 10%. But that makes a difference at these like extreme ends of performance. And it does add, from what I hear, a lot of time to the build process. It's kind of like, I want, like, this is like, you've heard of like, -02, -03 in terms of like optimization flags. This is like -O infinity, where it's just, I want you to throw almost everything at this. And so, for example, this is the reason, I think, why Firefox builds have always taken like 24 hours or more. And so if you're ever like, oh, there's this like 0 day in Firefox, why does it take them so long to actually get a new build out? It's because it literally takes them over a day to build Firefox. And I'm sure Chrome is the same way if you want to do a full like PGO build for distribution. And so now Rust also can use LLVM's support for this. And so kind of what it does is first you profile, as you may assume, or as you may infer, your program. So you run it in the background, you use it for a while, it figures out the hot paths, and then you use that profile during optimization, does like a full like build of Unity build of like all the files at once, and figures out like where are the best places to inline things, like what is the hottest function, where are we the most and where aren't we the most. Because usually when you do inlining in a compiler, you're kind of just guessing. You're like, well, this one wouldn't be too bad to inline because it doesn't increase my size too much, or that kind of thing. But if you actually have the information, you can do much better. So that's the idea. If you need extreme performance, then you should look into this. Other than that, you probably don't care. But it's cool that Rust supports it. It's kind of a sign of maturity for Rust, I think.
I wonder whether this is something we could use for the compiler itself.
I would like to, certainly.
That would be neat.
It's worth a try.
Continuing this trend, I think this is really a trend of this particular release, is this smaller features that just make life easier, but in small ways. Like it's almost like fixing paper cuts. So one thing that you may have run into if you write any project that has multiple binaries is that when you first have just one binary, you can just do cargo run. And then once you have multiple binaries, cargo will yell at you going, no, you have multiple binaries. I don't know which one to run. And now, finally, you have the ability to set the default binary. So now if I have binaries foo and bar, I can now say, when I run cargo run bar. So now instead of doing cargo run -- bin bar or cargo run -- bin foo, if I leave off the bin part, it'll run the default one that I specify.
Yeah, we were immediately at my work using that for a project we have. So it was just so useful and so fortuitous that it came right then.
Yeah, because I think often you have a bunch of auxiliary binaries that are just for debugging or like minor stuff, and then you have the binary, which is the one you usually want to use.
Yeah. Do you want to go over some library changes in this release?
Yeah, we can do that. Let's first talk briefly about this this alignment of enums repr.
Okay.
Yeah, so
you take care of that.
Yeah, I mean this is also a pretty niche feature. Previously, you've been able to give the memory alignment of structs and other types, but you couldn't do it for enums, and now this is supported for enums as well. And the in-memory representation is as if you had a new type struct with that alignment that just contained the enum. So it's going to align the whole thing, including the discriminant of the enum, and that's really all. It's just plugging a hole that was obvious to plug.
If you don't care about the alignment of your enum discriminants, you probably don't care. That probably is almost everybody.
Yeah, that sounds about right.
So, but Rust is a systems language, and we have to cater to everybody. It is our curse. Now, library changes. There are two ones on buffers. Buffwriter and buffwriter buffer.
So this is actually a change that started because a project I was developing at MIT needed it. And then I submitted the first PR to this, and then my lab mate submitted the final PR, which is what just stabilized. And so this is the ability to peek at the bytes that have been buffered by a buff read or a buff write. So a buff reader and a buff writer, what they do is they keep an internal buffer, which should be evident from the name, of the bytes that will be written or read. So this is so that you cross to the operating system less frequently. So if you want to do a write, then you might not want to do write system calls for every single character you write or something. You might want to accumulate a bunch of them in a buffer first, and then eventually flush them out to the operating system. And previously, once you had given them to a buff writer, or if the buff reader had buffered some things and not given them to you yet, you had no way of getting at those bytes. Whereas now there's a method called buffer that gives you a slice of U8s of the stuff that has been buffered. And this is really handy if you're writing things like network protocol parsers, where you might care about the bytes. You might care about whether or not buff reader or buff writer will go to the operating system if you call them again. We also have this, there's been a little bit of love given to option in that we've now gotten the XOR method to option. Do you want to tell people what this is?
Yeah, I mean, as the name might imply, it gives you an XOR, like say like a bitwise XOR or a logical XOR, is only true if exactly one of the two inputs is true. And so this XOR on option will return some if exactly one of the two inputs is sum. Otherwise, returns none. So if you give it like a sum1 and a sum2, you get none. So it's interesting, neat. It's kind of, I think it exemplifies how Rust's standard library is a very deep library. It often gets, you often hear people say Rust library is small, which is not the case. It's actually pretty big, but it has fewer overall modules than Python's, say. But what it does provide is very extensive. It tries to give you all the convenience things that you need to get things done. And so if it does provide, like, so for string types or option types or any of these, we give you tons of ways of doing things easily, hopefully. So
yeah,
kind of an ergonomics thing.
When I saw option XOR, it immediately reminded me of the transpose method that exists on option and result. Mm-hmm. This has been stabilized for a while, but it lets you take an option result and turn it into a result option, and the other way around. And this is also only for convenience. It's not very hard to do this in your own code, but if you need it, it is really handy to have this method available.
Speaking of that transpose, there's one just like it, this cell as slice of cells. Do you want to go over that?
Yeah, so cell is a weird beast that some of you may have encountered before, and cell represents the notion that it's okay to atomically swap a value in a single thread. Like if you're in single thread context and you have a pointer to something, it's okay to replace that pointer if no one else has a pointer to it. So to give a little bit more context around this, imagine that you have an immutable reference to a cell. You know that no one else has a mutable reference to that cell because the borrow checker would prevent you from doing that. And then if you just swapped out the value, no one else could possibly observe that you did that. They can't have a handle to the thing you're operating on under the normal borrow check rules, as long as there aren't multiple threads involved. So cell is not send or sync.
to be clear, I think we missed our segue there, where you're talking about cell from mute.
Yes.
I was talking about cell as slice of cells.
Yes. So I was trying to basically introduce what cell is for those who might not be familiar with it. And now the cool thing about cell is that it is really only a type level construct. It doesn't actually do anything to the type. All it really is if you have a cell T, it's really just a T with some additional contract around it. And that means that because it's transparent, you can sort of just add and remove cell wrappers as you wish. So this means that, and this is where we get into what has been stabilized now, is if you have a cell of a slice of T, then you can turn this into a slice of cell of T, because in memory, they're the same representation. And this is kind of neat. This just magically works out and still gives you the same abilities that you would have with cell. And the reason you might want to do this is now you can swap out the values for any given item in the cell sort of concurrently, so to speak. We also got this cell from mute, which lets you take a mutable reference to a T and gives you an immutable reference to a cell of T, which if you just spend some time looking at that signature, it's amazing that this is a thing. It's so weird, but it's kind of cool that this works out and that this doesn't break any of Rust's safety guarantees. Unclear that you'll need it, but it's neat.
Yeah, it's possible to do, so might as well put it in the library where we put all the convenient things. We want Rust to be convenient. So as long as we have good library documentation, there's no problem with that. And then what's next?
So we have this, if you look at the bottom of the release announcement as well, there's a really cool thing that's happened to the Rust project recently. Do you want to dive into this a little?
Sure. So as you may expect, a project like Rust, everyone does like builds every day. So every single PR that gets pushed, there is a CI that gets done, and we store that build somewhere for bisecting later if there's some kind of failure or regression. And so, like so every time that CI has built a Rust C build for every PR for the past 3 months, those binaries are all stored, and that costs money, as you may imagine, for both like transfer and all this, and also the transfer of our actual like distributions for nightly and stable and all that. And the CI itself costs money. And so this is really the single largest expense of the Rust project. Maybe like there's maybe salary of a few employees like Nico, but the like biggest ongoing expense in terms of like infrastructure is this CI and storage costs. And it just so happens that Microsoft and Amazon have both stepped up to offer us free storage Microsoft offers us Azure instances to do our CI on, which is great, just for free, so sponsoring that. And then Amazon has offered up their S3 for storing all of these things for free. So I think it's a few years we have this contract on, so it's a great news for us, and it's great that we have this like diversification of previously Mozilla did all of this, which is great. Let's also thank them for doing it for the past how many years, and now they can maybe put some more money towards being a charity. And Amazon can do this, Microsoft can do that, and I think both Amazon and Microsoft both use Rust for both these services. So it's kind of like dogfooding almost.
It's also cool, I think, to see both that Rust is gaining more traction in like the business world to the point where Microsoft and Amazon are willing to do this, but also that we see multiple companies stepping up. So it's not as though sort of just Microsoft is going, we're going to be running Rust now, right? But rather, we now have Mozilla, we have Microsoft, we have Amazon running stuff. And there was this neat blog post recently by Facebook that they're using Rust as well for their Libra project.
So Facebook is interesting. They're using Libra, or they're using Rust for their Libra cryptocurrency or blockchain. I'm unclear. But I think they're using async await heavily. And similarly, I might also mention Google's Fuchsia project, also a very important user of async await, involved heavily in the stabilization process, kind of for proving out, like, does this work? Is it actually, like, meeting your performance goals and ergonomics goals and that kind of thing? And so Facebook has a great blog post up about we ported our things from the previous old style async await to new style async await, kind of the old, like, combinators versus the new async await actual syntax, which, speaking of the syntax, the reason why we're talking about this is that the news is that was finally stabilized in nightly. So that will be arriving in 1.39, which should come in October or sometime like that, in like 10 weeks from recording.
Yeah, something like that.
I don't know. Yeah, so it's exciting.
It's pretty exciting. So the stabilization PR landed August 20th, which means that it only barely missed the deadline for 138.
Yeah, for a while, it was kind of the big news was like, we're going to aim for 138. We're going to make it. And then like the day of, it's like, it's so close, but we don't want to do it. We don't want to rush it.
And I think this speaks volumes to the I don't know if maturity is the right word, but I liked that the process was such that the decision was made to look, let's not do this for 138. We're going to do it for 139 because we don't want to rush this. We want to get it right.
Yeah, we all want it, obviously. Or I mean, I guess it's kind of one of those features where you either don't care at all because you aren't doing async stuff, or you really care because you're painfully doing this async stuff, like kind of writing all these state machines manually by hand. And so for plenty of us who do care, it is a big feature that we're kind of like, we're bummed that it didn't make it for 1.38, but we're happy that there's progress. There is a date now for it coming. And I mean, in some sense, it's not a bad thing that it gets more time in testing because this is a big feature, generators and all of that.
And the ecosystem has to move with it too.
Yeah.
I mean, we now have alphas of most of the relevant crates in the ecosystem, but nonetheless giving them a little bit more time to just sort of brew in that and get ready for the final release and stabilization, I think is going to be good.
And I guess in some ways too, it's also kind of like, this is the point of Rust's rapid release process, is to, if say we did once a year and the like date was like August 10th or 6th or whatever it was, and it's kind of like, well, we could like push everything back for a week or longer to wait for this feature, or we wait an entire another year for it, where it was like, people would be a bit, I think, more angry. But having to only wait 6 weeks is reasonable.
Yeah, I think that's probably what enables us to say no to things, and we'll do it next time.
Yeah.
We have a bunch of people to thank, given that we've managed to do so much stuff since last time. Before we get into that, though, I want to take a little bit of time just to give a brief shout out to some features that didn't make it into the release notes or the release announcement.
Go ahead.
But that have landed. So the first is that cargo package will now include the cargo lock file of projects that have executables in them. So previously, if you did cargo install, for example, cargo install didn't have access to the cargo lock file of the project you were installing. Now the cargo lock file will be included, and so now you can actually install the same versions as the author used when publishing, which means that in theory you should have fewer errors when you try to install something. I think you might have to pass --frozen for now to cargo install, but hopefully this is something that will sort of wiggle out and we'll get fewer errors of, I tried to run cargo install and it didn't work. We also have some changes where now you can use some of the 2018 macro patterns in 2015 macros, which matters for a very small part of the community, but for them it matters a lot. And finally, if you try to use trait objects now without the din keyword, that will now give a warning from the compiler. So this is moving towards this eventual deprecation of bare traits. So I think for the next Rust edition, I think at least the goal will be to reuse bare traits for something else.
Remains to be seen. I'm not sure, actually. I think, so the plan was originally to, people wanted to be able to kind of like write, my function returns this and have it just mean impl trait, but you couldn't do that because returning like the name of a trait means the trait object in Rust 2015. But actually, after using impl trait, I kind of like the explicit thing there. I don't know if impl, it was a long bike shed to be like, is impl the right word? Everyone's like, not really, but it's the best word we have.
Yeah, I agree. I also like the keyword.
I kind of like the keyword there.
I agree. I wonder.
I wouldn't oppose removing it, but like, it's kind of nice.
I wonder whether what we'll see is that when eventually the sort of bare trait gets freed up, that it might turn out to be useful for something else, but I don't quite know yet.
Well, I think just like how it's really useful, because so for me, it's a surprise to hear that din was not already required by the new edition, because I kind of just already use it that way, because it's really useful to know when a thing is a trait object, just because it has a lot of ramifications for like, where can I use this, how can I use this, and similarly, if you have an impl trait, first of all, it just means that you know about like, how can I use this? Well, in certain ways, but not in others, at least not right now, and in other ways too. Like, it lets us talk about this in a very like way where it's kind of like we say impl-trait. If we didn't have impl there, we would need to have like terminology differences and that kind of thing.
And now we're about to get existential types soon too, which is going to be so neat.
Impl-trait already is that, I think.
Yeah.
And so, but I don't want to say that word ever. 'Cause
existential
people get
is
scared.
fantastic.
It's a scary word.
Oh man,
It's like
it's going to be.
It's too math.
Yeah, that's true.
People don't like math.
I think existentials are something that only matters if you're writing like really low level libraries, low level in the sense of the type system. Like if you're implementing like the future trait yourself or something relatively deep down in the system, then they're useful. And they just make, this is sort of like the other things we've talked about for this release, that higher level things, higher level APIs become nicer because you can use lower level constructs.
Yeah, it's definitely one of those things, a feature of both Rust and C++, where the idea is library authors can, if they want, contort themselves into like doing very painful things to make their APIs very nice to use at the end, and no one has to know.
Yep.
So,
all right. So with that, I think we're through the 137 release.
I believe
and
we are.
We're now looking forward to the 138 and eventually 139 release. And I think it's time we thank some people.
So actually, I want to thank you, John.
Aww.
First of all, for doing all of the technical things. You set up all the GitHub pages stuff, and you have all the hosting stuff and all the podcast indexing stuff. Took a long time, from what I hear, I imagine. So it sounds totally infuriating, and I'm happy that I did not have to do it. So thank you for doing that.
No, it was. I don't want to say it was fun, but there was certainly a lot of frustration over various RSS formats and how to make everything work together. But I want to thank you, Ben, for having the idea to do this in the first place and having the sort of drive to make us do it. I think without you, this wouldn't have happened. We need someone to step to the forefront and make it happen. And you did that.
Yeah, well, you're welcome. I mean, there was a lot of energy in the room for doing things. And so kind of just saw that and was like, this needs to be harnessed. So brought everyone together, and then this resulted. So it's going great so far. I wanted to kind of like use this time to reflect on the first 2 months. This is our 4th episode, I think. And so the idea of the entire podcast series was to do this crowdsourced, is that the right word for this? Where mostly we can kind of just be like, hey, like we have all the stuff you need to do a podcast, all the boring stuff like getting all the podcast indexes to index your RSS feed and having an RSS feed in the first place. And then you just like throw audio files at it and it just works. And so we weren't really sure if it was going to actually attract anyone. And we have attracted people in every single role.
Yeah, because it's not just us now.
Yeah.
In fact, we've mostly been gone for a while, and still 3 more episodes have released since the last time the two of us sat down.
And 2 of them had like me as the host still. First of all, let's thank Abdu Sek, my host in episode 2, Ruma and Matrix. So people who want to co-host, great. I want to also thank, I don't know their last name, and their nick is Jeremy. I think Jeremy Young, possibly, on the Discord for wanting to do some interviews himself. I think he has already reached out to Armin Runisher, the person who does Redis, Rust Redis, and then I forget the name of the library that has really nice command line progress bars. Anyway, Armin's a great guy, does really good work in Python as well. I think he's the Flask guy or one of those framework things in Python. But yeah, it should be a hopefully good episode if it ever happens, but I don't want to get your hopes up. We'll see. Also, I want to thank Chris Krako for kind of being the one to blaze all the trails here and then guide us in doing this. I want to thank Reese McMillan for editing all of our podcasts and doing all the audio touch-up. It's great to have somebody with that specific skill set around because that was kind of the one thing I was worried about where it's like I could like maybe apply a single filter to the entire audio file, but I don't know a dang thing about how to actually use this competently. And so thanks so much, Reese.
And Reese has also given us some pointers for how to get the audio better for the episodes as we go along. So hopefully the audio now is better than the audio was in the first episode.
Mm-hmm. I want to also especially thank the people who stepped forward and said, hey, interview me, because that's kind of the entire point, is to find people to talk about Rust. So I want to thank Jimmy Quadra, who you may recall from the episode on Matrix and Ruma, and then Jay Haig, who is the organizer of Colorado Gold Rust. They kind of just both approached us and they were saying, hey, come talk to us. And if there's anyone else out there who wants to just have us talk to you and about whatever Rust project you're doing or just talk about a cool thing that you're doing in Rust, let us know. This is so far going really well.
Or for that matter, if you want to talk to other people, like
Yeah,
if you have
that's
someone you think it would be exciting to talk to and for the
Forget
Rust
us.
community to
We're
learn
boring.
about. Yeah, exactly. Like ideally, we should not be relevant.
Yeah, let's obviate ourselves and totally. So that sounds fantastic. Enjoy a leisurely retirement.
And the process is really easy now too. If you want to do some kind of podcast, we'll help you get set up to do the recording, and then you just submit the audio file and we'll make sure it gets fixed up the way it needs to be. And then releasing the episode is really straightforward now. You've done a few releases
fantastic.
now
It's just you
while I was away.
submit a PR, review the PR, merge the PR, and it's done. And it's so seamless. I love it.
And then it's immediately
great.
released on like all the podcast platforms.
Yeah. I want to also thank Andrew Gallant, also known as Burnt Sushi, for offering us getting us a nice recording room for the first episode, and then Abdusek for episode 2. And then this one, we are currently in the Boston Public Library. So I want to thank libraries everywhere for being awesome. They have just the microphones that we're using, and GarageBand, and cool like audio dampened walls and screens. And also, I learned yesterday, some libraries have like cake pans and seeds and all kinds of crazy things. So go to your library.
It does say on the wall here, though, that we're not allowed to produce anything that has objectionable content.
Okay.
So we need to be really careful.
Really
about
careful.
Saying anything about like unsafe or something.
Unsafe. Can't say unsafe.
No
here at all.
unsafe in this room.
Okay. Also, let's thank the Rust community as well for being awesome in the first place to inspire us to do this for all of you.
Yeah, and I think all of the people involved with the development of Rust as well, we wouldn't be here if you hadn't produced an amazing language and continue to produce an amazing language. And that's amazing.
Amazing.
We do have one request, though, before we sort of sign off. Is that the right terminology?
We're podcasters now.
Which is that Reese, our audio engineer, is about to start...
Yeah, going back to school. So it was summertime when he was doing all of our previous episodes. And so if you would like to step up and take some of the burden off of him, let us know.
In theory, it's relatively straightforward. We give you some audio clips, and then you make them sound as good as possible given our somewhat weird voices. And then we publish it, and then we talk about you at the end of the episode.
Yeah. Oh, also, I wanted to thank, too, Jeremy Young as well, did the show notes for the previous episode.
Oh, yeah.
The one with Colorado Gold Rust. And so that's usually my job. It's usually kind of like, like the last thing to do, and I'm already tired, and I'm busy. So thanks so much, Jeremy.
And with that, I guess the last thank we have to give is thank you to everyone who sits through and listens to all these episodes. That they subject their ears to us and our rambling.
Mm-hmm. We'll hope you enjoyed our rambling this time.
That's right. And then I guess hopefully it won't be that long until the next episode. There'll be 6 weeks or probably a little bit less until we do the 138 episode. Mm-hmm. And in the meantime, I think there are already some episodes in the pipeline.
There's the one that I mentioned with Jeremy and Armin Manisher. Hopefully, I'm not sure when that's going to happen. And then if anyone else, I might find a few folks to do things with in the meantime. Or maybe you will. Who knows?
It's exciting. Anything is possible, Ben.
Everything is possible.
And with that, I think we're going to drop ourselves and go out of scope.
Oh, no.
Oh, no. You couldn't wait for that joke.
We're done.
Bye.
Sign off.